How come there are plastics everywhere?
Because they're everywhere.
I mean, they're affordable, they make life comfortable. How come I interact with so many plastics a day and yet there are still enough to grow?
The answer is back to an awesome profession, chemical engineering.
Before the Industrial Revolution in the 18th century, industrial chemicals and other consumer products such as soap were mainly produced through batch processing. The methods available then were generally labor-intensive, slower and inefficient. To solve this problem, a new line of professionals were born, chemical engineers. By the 1880s, the engineering elements required to control chemical processes were being recognized as a profession. Chemical engineering began in the United Kingdom after the first chemical engineering course was given at the University of Manchester in 1887 by George E. Davis. So, what exactly do we do? Chemical engineers do the math, the science, and engineering that make modern production easy and possible. Today, chemical engineering is highly regarded as a profession, specializing on unit operation processes, chemical kinetics, chemical reaction engineering, transport phenomena, process designs, and chemical thermodynamics.
Centralia, humans have learned how to make synthetic polymers, sometimes using natural substances like cellulose, but more often using the plentiful carbon atoms provided by petroleum and other fossil fuels. Synthetic polymer was invented in 1869 by John Wesley Hyatt, who was inspired by New York firm's offer of $1,000 for anyone who could provide a substitute for iron. The growing popularity of brilliants has put a strain on the supply of natural iron obtained from the slaughter of wild elephants. Using cellulose derived from cotton fiber with camphor, Hyatt discovered that the plastic could be crafted into a variety of shapes and made to imitate natural substances like turtle shell, horn, linen, and even ivory.
Chemical engineers produce plastic from various sources like petroleum and vegetable matter. They apply various chemical engineering principles to produce polymer resins through various processes such as polymer synthesis, condensation reaction, addition reaction, and so on. Chemical engineers design safe reactors using inherently safer design to turn polymer resins into plastic products using various processes such as injection molding, extrusion, blow molding, and rotational molding. Additives are added to base polymer resins to give plastics different characteristics. This is why we notice a wide number of differences between various plastic products. It is the role of chemical engineers to maintain a safe and green environment. This is why chemical engineers are concerned about the toxicity of plastics. Plastics are very durable materials which barely degrade with time. This means all the plastics produced remain somewhere. This accumulation is responsible for the huge plastic pollution we face globally. Plastics buried in landfills can leach harmful chemicals into the soil, which may end up in groundwaters and large water bodies. Some countries dump their plastic waste in large water bodies. As a result of this, ingestion of plastic materials are very high in marine animals. Carnivorous birds and animals that feed on these marine animals end up having plastic toxins in them as well. Studies have shown that humans also end up having plastic toxins in them when we feed on these animals. A better alternative to plastics are bioplastics.
Oh my, when we use plastics in a whole lot of things, how then do we reduce this level of toxicity? We recycle them. This is basically the conversion of waste plastic into useful and functional products. According to the SPI classification system in 1988, there are 7 classes of plastics, of which only 4 kinds can actually be recycled. These 4 kinds are the ones found in items ranging from the grocery bags to toys. Now, how do we carry out this recycling process? First, we gather the plastic materials to be recycled, of course. We sort them based on the type, the resin content, the color, or even based on the mode of production. We wash them to remove the non-plastic debris. We resize them by shredding or granulating them. Then, we categorize them to determine the quality and the class by carrying out tests such as the density test, the melting point test, or even the hair classification test. Now here comes the fun part. We smash and melt this plastic into small pellets that can be used in the production of new plastic products. Let's also try to save the environment by living by the 3 R's. Reduce the amount of plastic you use, reuse those you already have, and recycle those that